Good morning, everybody. Welcome back to science class. Today, our topic is topic 6.5, pressure. So this word pressure has always been used in our daily lives, but mainly people use pressure as a means to express something to do with their mental health. So when you feel a lot of pressure, that means that you feel really stressed out. And that usually is associated with a feeling of having something pressing onto your heart or even onto your head. But today we're going to have a look at what pressure actually is in terms of the scientific definition of pressure. And you can see how it actually relates to how we use the word pressure in our daily lives as well. But before that, let's do a recap of our previous lessons, and we covered 6.3, measurement of forces and calculating work done. So firstly, forces are measured by using an instrument which is called the spring balance. And we stated the SI unit for force, which is Newton. So force is always measured in Newton, and work done is defined as the product of the force and the distance moved in the direction of the force. We calculated work done by using this formula. Work done is equals to force times distance moved in the direction of the force, and the SI unit for work done is in joules. SI unit for force is always in Newton, and the distance moved we always use meter. And we also could calculate work done by looking at this triangle, where we put force at the bottom, work done at the top, and distance at the bottom. State the unit for work done. So work done is always measured in joules. So our new learning objectives for today, firstly, is to define pressure as force per unit area. Secondly, to relate pressure with force and area and calculate pressure using this equation. Pressure equals to force divided by area. Our last learning objective is to state the SI unit for pressure, which is Newton per square meter or Pascal. And also the fact that 1 Newton per meter square is equals to 1 Pascal. But just so you know, we also use the unit Newton per centimeter square, especially in calculations. However, Newton per centimeter square, or 1 Newton per centimeter square, is not equals to 1 Pascal. And we'll talk about that later. So what is our step to success today? Firstly is to state the definition of pressure. Secondly, to state the formula for calculating pressure. And thirdly, to state the SI units for pressure. So forces and pressure, this main topic 6 is forces, but how does it relate to pressure? When an amount of force is acting in an area, we get pressure. And that's why we have that saying where we're under so much pressure. And we're talking about stress here, the fact that we feel like there's a force pressing onto our heads and our hearts. And that is what we mean by pressure, is that there's a force acting on an area. But this time it is scientific, so we should be able to measure that pressure and we should be able to measure that area. So how do we define pressure in a full sentence? We can use this. This is the long definition. Pressure is a force exerted by the substance per unit area on another substance. Or if you want to use a shorter definition, pressure is the force per unit area. How do we calculate pressure? Pressure is calculated using this formula. Pressure is equals to force divided by area. Remember that pressure is in the unit Pascal, force is in Newton, and area is in meter square. But we have other units for pressure, which is which is in Newton per meter square or Newton per centimeter square. And how do we calculate pressure? We can form this triangle. So we use this triangle before when calculating work done, which is we put the W at the top, F, and then D. However, for pressure, it's P, F, and A, and F, the force, is at the top of the triangle. And remember that anything below this triangle you divide, and anything right next to it is times. And for pressure is in Pascal or in Newton per meter square or Newton per centimeter square. Force is always in Newton and area is in meter square, or it can be in centimeter square. As a unit for pressure, again, so I'm gonna just elaborate this for you guys. It can either be in Newton per square meters, which is this one right here. I usually say Newton per meter square just so it's easier for you guys to write it down and remember it, but people usually actually look at this and describe it as Newton per square meters. But I'm just gonna read it one by one, so I would say Newton per meter square so that it's easier for you guys to write down. And another unit for pressure is Pascal. So how do those two things relate to each other? So 1 Newton per meter square is actually equals to 1 Pascal. However, you can also use this unit for pressure when we're calculating. We can use over here Newton per centimeter square. So 1 Newton per cm square, because we changed the meter into now centimeter square, it is not equals to 1 Pascal. So how much is 1 Newton per cm square in terms of Pascal? 1 Newton per cm square is actually equals to 10,000 Pascal. So if we want to reduce that number, we can simplify that. So 1 Newton per centimeter square is equals to 10 kilopascal instead. So this is how you can relate Newton per meter square to Pascal or Newton per centimeter square to Pascal. So now we're going to try to apply the working that we have learned, that formula itself, to calculate pressure. So this is our first question. An elephant is walking on a tiled floor. If the weight of that elephant is 40,000 Newton and the area of each foot is 1,000 cm square, how much is the pressure that the elephant is exerting on the tiled floor? So you can see here an elephant and the floor is tiled, and we're going to calculate how much pressure each of the foot, all together, not each of the foot, but all of these feet, because the elephant itself has 4 feet, how much pressure is it exerting onto that tile itself. So remember, when we're trying to calculate, we always try to draw our triangle. So this is the triangle that we have today. It's a slightly bit complicated than our work done triangle because it does include different units. So we have here force. Force is always in Newton, and I'm just going to change this into a laser pointer. Okay, and you have pressure, which can be in Newton per meter square or Newton per centimeter square, or it can be in Pascal. Area is in meter square or centimeter square, but note the fact that 1 Newton per meter square is equals to 1 Pascal. However, 1 Newton per cm square is not equals to 1 Pascal. It is equals to 10 kilopascal. Okay, now we got all of that sorted. We're here to calculate pressure. So remember, you circle pressure, and what is left here is force and area. So when you have force and you have this line right here, that means force is divided by area. So what will be our formula? So our formula is pressure equals to force over A for area. So where is the pressure that we're looking at here? Pressure we're looking at is weight, which is in 40,000 newtons. And the area here, remember that we're looking at area for each foot is 1,000 centimeters square. However, this elephant has 4 feet. So how do we calculate that? It's going to look like this. 40,000 divided by 1,000 cm square times 4, because of the fact that the elephant itself has 4 numbers of feet. And this would be equals to 40,000 Newton divided by 4,000 cm square, and we have 10 Newton per cm square. So Newton per cm square is a unit we can use for pressure, as you can see over here. So that means that the total pressure that this elephant is exerting onto the tile is 10 Newton per per cm square. How about we change it up a little? Instead of an elephant, we have a pair of heels. So a person is walking on a tiled floor in a pair of heels. If the weight of that person is 400 Newton and the area of each shoe heel, so again, each shoe heel is 2 cm square, how much pressure is the person exerting on the tiled floor? So let's draw our triangle again, just to help us remember everything. Okay, force is always in Newton. Pressure can either be in Newton per meter square, Newton per centimeter square, or Pascal, depending on the question. Area is always in meter square or centimeter square, depending on the question. And over here, we can see that the area is in centimeter square. So we can use this unit right here. And we are here to calculate pressure. So that means it's force divided by area. So P equals to F over A. And F here we're looking at is 400 newtons. And area, which is A over here, it is 2 centimeters square for each shoe heel. So each means one of it. However, the person is wearing 2 pairs of shoes. I mean, 1 pair of shoes with 2 heels. Sorry. So you can see here 1 heel and 2 heel. That's why we times it by 2. So altogether, this is 400 Newton divided by 4 centimeters square. And the answer we get here is 100 Newton per cm square. So this is the total pressure that both the heels are exerting onto the tiled floor is 100 Newton per cm square. There are 2 factors that are related to pressure. Pressure depends on 2 main factors. The first thing is the size of that force. Secondly is the area of contact. So that force acting on the area. And the reason for this is because of the formula itself, because pressure is equals to force divided by area. So therefore, if the size of the force is greater or the size of the area is greater, it's going to affect how much pressure there is. So let's have a look at the relationship between force and pressure. So let's use our examples from before. We have the elephant and the person walking in a pair of heels that are walking on the tiled floor. So if we have a look at this question, which will damage the floor more? Would it be the elephant or the heels of the person's shoe? So we have calculated this. So the elephant is exerting 10 Newton per cm square, that much pressure onto the tiled floor. However, the heels, person wearing heels, is exerting 100 Newton per cm square. That is how much pressure they're exerting on the floor. So obviously we have a greater number here that is exerted. So pressure is exerted higher on the pair of heels than the elephant. So here the answer we can write down is the pressure of the shoe heels. You can see here is actually 10 times greater than the elephant's feet. The heels will actually damage the floor more because it exerts more pressure onto the tiled floor. But how come something so small has much greater damage? And also, obviously, the person will be much more lighter, and the force that we're talking about here, which is weight, is much more less of the person rather than the elephant. The elephant would definitely have a greater force. So this is the relationship between force and pressure. The fact that when the force exerted is larger, therefore pressure is greater, right? However, the larger the area of contact, so the higher the area, pressure becomes lower. So looking back at that example, because the elephant has a larger area per feet, the area of contact is larger, therefore pressure becomes smaller. So remember that pressure would decrease as area increases. That's why pressure exerted onto the floor by the elephant is much more less. So it is smaller because of the area of each foot is greater as compared to the heels, where you have a very, very small area. So that means that as area becomes smaller, pressure would be the opposite. It will get even bigger. So how do we have this? How do we apply pressure in daily lives? We have these pair of shoes, which is football boots. Sorry about that. That was my alarm. Okay, so these football boots right here, they have studs at the bottom, and they're a bit much more special because of these studs. And you can see that these studs, they have very, very small area, pretty much similar to the heels. So the stud on the football boots would increase pressure because of the smaller area. It means pressure would increase on the ground, preventing players from slipping. They want to exert more pressure on the ground so that you have greater friction so that the football players won't slip when they are on the ground. Another thing that can be on the ground is here. This is a bulldozer, and the steel tracks is this part right here. You can see that the steel tracks have large surface area. The bulldozer itself is clearly very heavy. The weight, the force, which is the weight, will be definitely great. So we're afraid of it sinking into the ground instead. So we want to have the steel tracks to have large surface area to allow their weight to be spread over a large area so it can avoid sinking onto the ground. Now that we're done, let's look at our step to success. Firstly is to state the definition of pressure. Second, to state the formula for calculating pressure. And the third one is to state the SI unit for pressure. So the definition of pressure we can have is this one. Pressure is a force exerted by the substance per unit area on another substance, or pressure is the force per unit area. How do we calculate pressure? We use this formula: pressure equals to force divided by area. Remember that pressure is in Pascal. It can be in Newton per meter square or Newton per centimeter square. Force is always in Newton, and area is always in meter square or centimeter square. State the formula for calculating pressure. Again, we can use this triangle where we put P at the bottom, which is pressure at the bottom, F at the top, and area at the bottom. And whenever you have this line, it means divide, and when they're next to each other, it's always times. Pressure is in Pascal. It can be in Newton per meter square or Newton per centimeter square, depending on the working itself and the units that are used. Force is always in Newton, and area can either be in meter square or centimeter square, just like how we used it with the elephant and the heels. Lastly, state the SI unit for pressure. Usually it's in Newton per meter square or Pascal. However, in calculations, we can use Newton per centimeter square. So that is all for today, and we finally finished the topic forces. So I hope you guys have a good day today. Stay healthy and safe. Don't forget to eat 3 times a day. Bye everybody.